Hey everybody, it's Mrs. T from Mrs. T's Chem Talk. This is going to be Mrs. T Chem Talk AP Chem acid-base video 2. We're going to find the pH of a weak base, and we're going to find the pH of salts, salt of weak acid and salt of weak base.
If you are asked about the pH of a weak base, a Kb will have to be given, and you might be asked to find the pH of a weak base, B. If the Kb is equal to 2.3 times 10 to the minus 7, and perhaps they'll tell you that the base has a concentration of 0.02 molar. The reaction that will drive this would be B plus H2O yields HB plus OH minus. The Kb expression, which is on your table, is OH minus times HB plus over B. This would be our typical Bronsted-Lowry base that acts by accepting an H from the water. We would set the Kb equal to x squared over initial, just like when we were doing the weak acids, only in this case x is going to give us the hydroxide ion concentration. So when we negative log that, we're going to get the POH, not the pH. So we're going to set that Kb of 2.3 times 10 to the minus 7 equal to x squared over 0.02. The x that comes out of the calculator is 6.78233 times 10 to the minus 5 molar, which again is equal to our OH minus concentration because it was part of the Kb. If we negative log our x, we get the POH, which was equal to 4.17. And if we do 14 minus POH, we get the pH of 9.83. If we want to find the pH of the salt of a weak acid, question might say something like, find the pH of a 0.1 molar sodium acetate solution, where they give you the fact that acetic acid has a Ka of 1.8 times 10 to the minus 5. This salt comes from sodium and acetate. Sodium hydroxide is a strong base, so sodium ions will not contribute to the pH, but acetic acid is a weak acid, so the salt or the conjugate will act basic. When that happens, since it's going to act like a base, it's going to somehow release hydroxide in water. So C2H3O2 minus will react with water to accept the hydrogen, making undissociated acid and releasing hydroxide ions in solution. Since this is going to act like a base, we need a Kb. So how do we find that Kb? We Kw the Ka to get the Kb. So we do 1 times 10 to the negative 14 divided by the Ka, and when that comes out of the calculator, that will be the Kb of our salt. Now that we have a Kb, we treat this as any other weak base, and we're just going to set Kb equal to x squared over the initial which means we're going to do 5.56 times 10 to the minus 10 and set it equal to x squared over 0.1. X will give us our hydroxide ion concentration because of the fact that we were starting with a Kb. That hydroxide ion concentration came out to 7.46 times 10 to the minus 6 molar. When we negative log that, we get the pOH of 5.13. When we subtract from 14, our pH comes out to 8.87, which makes sense because this is a basic salt, so the pH should be above 7. If they ask you to find the pH of a salt of a weak base, for example, if they give you a question that says find the pH of 0.3 molar ammonium chloride, and they tell you that ammonia has a Kb of 1.8 times 10 to the minus 5. Ammonium chloride comes from ammonia, which is a weak base, and hydrochloric acid, which is a strong acid. So the chloride will not contribute to the pH, but the ammonium will act like an acid. When it goes into water, NH4+ will donate a hydrogen or a proton to water, releasing hydronium and contributing to more undissociated base. Since ammonium will act like an acid, we need a Ka. So we are going to Kw the Kb to get the Ka. We're going to do 1 times 10 to the minus 14 divided by 1.8 times 10 to the minus 5 to get the K value, the Ka value of the weak acid. Once we have that Ka, we are going to treat this salt like any other weak acid, and we are going to set Ka equal to x squared over the initial, where x now will equal our H plus or our H3O plus concentration. So if we negative log our x, we will get our pH. So we will set the Ka of 5.56 times 10 to the minus 10 equal to x squared over 0.3. My x equals my H plus concentration, which is 1.29 times 10 to the minus 5 molar. And when I negative log that, I get a pH of 4.89, which makes sense because the salt of a weak base will have an acidic pH.